Here's the next question, number 16. The synchronous generator shown in the figure is supplying active power to an infinite bus via two short lossless transmission lines and is initially in steady state. The mechanical power input to the generator and the voltage magnitude E are constant. If one line is tripped at time t1 by opening the circuit breakers at the two ends, although there is no fault, then it is seen that the generator undergoes a stable transient. Which one of the following waveforms of the rotor angle delta shows the transient correctly? Okay, so here is our diagram given to us. We have our source, the synchronous generator, and the two lines L1 and L2 connected to the infinite bus here. So the question says that the circuit breakers at both ends of line 1 are opened up. Now they are opened up even though there is no fault. Okay, so then it says that the generator undergoes a stable transient. So we have to figure out what the rotor angle delta would look like. Now the waveforms or the options, I have put them here on another sheet. So we have our options A, B, C, D. Please take a close look at these waveforms. You will see that at T1 for option A, the rotor angle has increased. In this case, the transient is almost in the same area. In option C, it has reduced tremendously, and in option D, it is in the same area but in the negative region. Okay, so here we will have to take note of a few things. When one of the lines is opened, like the question says, the equivalent reactance of the system is increased. Now that is important. How do we get that? We get that from the PE equation or the power equation. Okay, so basically we have the equation PE is equal to EV by X equivalent sine delta. Now this is the relation between the power and the rotor angle delta. So when one of the lines is opened, the equivalent reactance of the system, X equivalent here, will increase. Now this leads to a reduction in the power. So what happens is, now here we see from this equation, power is inversely proportional to reactance. So if reactance increases, what happens to the power? The power decreases, right? So this equation is the swing equation, really. Okay, so from the swing equation, what we see is when the power decreases, delta, the rotor starts accelerating. Okay, so when power decreases, the rotor accelerates. Now when the rotor accelerates, that implies that the rotor angle increases. So among these four options, the four waveforms here, which waveform indicates that the delta angle increases? There's just one. Option A. So this is why option A is the right answer. Well, this is the explanation and I hope it has helped.